Okay, this video is to help you with assignment 2.4C if you were having trouble with that. So you'll notice that up here at the beginning, we just have some information for you, okay? So this is how you can tell if a linear function is proportional or not proportional. There's three different ways that we can look at a function, okay? From points in a table, okay? If we have a proportional relationship from a table, that means that all of the ratios of the y over x will be the same. See, if we take 6 over 2, that's 3. If we go to the next one, that's 12 over 4, that's 3. 18 over 6, that's 3. And it goes through the point 0, 0, that's a good indication right there that it's going to be a proportional relationship. In a non-proportional relationship, then all the ratios are not the same. See, 10 divided by 2 is not the same as 16 over 4, because 10 over 2 is 5 and 16 over 4 is 4. See, they're not the same. So that one's not proportional. And it doesn't go through 0, 0, it goes through 0, 4, not proportional. So from a graph, a proportional relationship always goes through the origin. So straight line goes through the origin. The non-proportional linear function goes through some other y-intercept that is not 0. The y-intercept is not 0, it does not go through the origin. And then from an equation, actually the same thing is true from the graph. If the y-intercept is not 0, then we need it, okay? So we need this to be not 0 for it to be not proportional. But if we have the b value for y equals mx plus b is 0, then it is a proportional relationship because the y-intercept is 0, it goes through the origin. So we just have y equals m times x. So notice over here in the box, right? So we have y equals m times x because the y-intercept is 0, so we left it off. And sometimes the m, the slope, is also known as the constant of proportionality. And sometimes we use the letter k for that. So just in case you ever see that, then you'll know that, oh yeah, y equals k times x is the same thing as y equals m times x. They just use k for the constant of proportionality. That's the same as the slope. Okay? Now, on this next little part here, you have to actually solve these problems. I didn't give you any clues on that except to use proportional reasoning to do that. So we're going to do it like this. If y is 24, when x is 8, we're going to write the ratio, 24 over 8. Okay, that's the y, that's the x. And that's got to be equal to this y, which we don't know, over this x, which is 10. Okay, so now there's a couple different ways we could find that. Okay, so in a proportion, there's 3 different ways that I can think of that we can solve them pretty easily. One way is to just compare these two numbers to see if one of them is a multiple of the other one. For example, in this case, 24 is 8 times 3. Well, if that's true, then on this side, this top number has to be the bottom number times 3. So that's one way we can do it. Compare the top to the bottom. If it's a multiple, then the other side has to be the same multiple. So just multiply. You just have to find what you're multiplying by. 8 times 3 is 24, so 10 times 3 is the top number, so the y equals 30 on this one. Okay? Let's try the second one, and then we'll talk more about those as we go. Okay, if y is 23, when x is 4, find y when x is 5. Okay, so we put the y over the x on this side. We also have to put the y over the x on the other side. Now, 23 is not a multiple of 4. And 4 doesn't really multiply by anything easy to become 5. or to become 23. So on this one, we could do something called cross multiplying. And now if we cross multiply, we're going to multiply the denominator times the opposite numerator, like this, and turn it into an equation. If we do that, on one side of the equal sign, see, we keep the equal sign. On one side of the equal sign, we have 5 times 23. So 5 times 23, that's the bottom number on one side multiplied by the top number on the other side. Well, this is called cross multiplying. Well, 5 times 23 is about 115. And on the other side of the equal sign, we're going to take 4 times y. 4 times y. 4 times y is just 4y. So now we have an equation that we can solve. And on this one, we're just going to solve it by dividing by 4 divided by 4. So y equals whatever 115 divided by 4 is. Oh, let's see if I can work that out. 2 times 4 is 8, 35. So 8 times 4 is 32. So 3 left over, 0.75. So that was a difficult one. So like I said, there's 3 different ways we could solve a proportion, use proportional reasoning to find a missing number. That's 2 of the ways, okay? Find a multiplier, like we did here, and you have to find the same multiplier on the other side. So if the bottom number times 3 is the top number, the bottom number times 3 is the top number. If you can't find a multiplier, cross multiply. All right, so let's take a look at some of the other problems. So on this graph, we have to tell if it's proportional or not. So one thing you want to look at is, does the graph go through the origin? Yes, it does. So we're going to say that it is proportional. Now it also has to be a straight line, which it is. The rate of change you already know how to find. Just don't get it upside down. Rate of change, the change in y over the change in x. Don't forget to use the scale. The change in y goes from, let's see, this is 15 to 30. How far is it from 15 to 30? 15. The change in x goes from 10 to 20, so that's 10. So that's 15 over 10. Because remember, that's the change in y over the change in x. Now, if it's a proportional relationship, you could also just use the point. See this point right here? Okay. Take the y over the x. The y divided by the x. Because it's a proportional relationship, we can do this. Well, on that particular point that I circled in green, the y is 15 and the x is 10. It's the same answer. Okay, if you want to divide that, you can, because it divides nicely at 1.5. Now, the reason we want to divide it is because of the next problem where we want to write the equation relating x and y. So the rate of change, that's the slope, and we're going to write the slope, y equals m times x. We don't need the b because it's 0, remember? So that m is 1.5, so y equals 1.5x. Okay. Now we're going to solve, let's try this problem here. When y equals 15, x equals 10. So 15 over 10. So that's the y over the x. Find y when x equals 60. Okay, so on this one, here's what we can do. We can say, well, instead of finding, like we did earlier, we said 10 times some number is 15. We can go 10 times some number is 60. 10 times what is 60? Well, that would be 6. So 10 times 6 is 60. That means 15 times 6 is the y. So we can go across that way too. But whenever you go across or up and down with multiplying or dividing, never adding or subtracting. You can't say 10 plus 50 is 60 and then 15 plus 50. No, adding, no. Multiplying, yes. So 15 times 6 is 90, so y equals 90. Okay. Let's see, I think we can kind of verify that on the graph. Kind of, the x is 60 here, and if we went up to the line, which, oh, we don't quite have it, but we can tell it's gonna be some number above 70, or actually above 80, because 80 would be right there. So I think 90 is probably it. Okay. Number 2, consider the graph proportional relationship or not. Okay, does it go through the origin? No. So we're gonna say not. Rate of change. Okay, says be careful to use the scale. So I'm gonna go from this point to that point. Change in y. Oh, I have to know what this number is. What number is halfway between 24 and 32? See, I think it's gonna be about 28. Because 32 minus 24 is 8, and half of 8 is 4, so I just have to go up by 4. So this goes up by 4. So 4, 8, 12, 16, 20. Okay. So it goes from 28 to 32. So it goes up by 4. And it goes over from 4 to 6. So it only goes over 2. So remember, it's the change in y over the change in x. Now this one, we can't use the y over the x because it's not a proportional relationship. We have to use the change in y over the change in x. So the change in y is 4, the change in x is 2, and 4 divided by 2 is 2. Now in this one, the equation relating y and x, we have to use y equals mx plus b. We need the b because the b is not 0. So the 2 is our slope, that's the m, so y equals 2x plus the y-intercept, which is 20. That's the b number. So now if we want, if y equals 24 when x equals 2, y equals 24, that's this point right here. Okay, that point there is y equals 24 when x equals 2. See, it's 2, 24. Find y when x equals 10. Okay, now to do this one, we're going to take the x equals 10 and plug it into the equation right there, and y equals 2 times 10 plus 20. 2 times 10 is 20, so that's 20 plus 20. So y equals 40. And it says, compare your answer to what you get if you use the graph. Okay, so if x equals 10 on the graph, that would be way over here. Go up to the line. And then go over to the y. And it comes out to be 40, just like we said. 40. Okay. Starting to understand? That would be good. Problem number 3. For 3 different days of work, Odin has gotten paid according to the amounts in the table. Proportional relationship or not. Okay. Now we don't have a graph. So to find out if it's proportional, we have to do this. We have to take the y divided by the x, and it has to be consistent for each one of those. So we have to take 29.25 divided by 3, and then we have to take 48.75 divided by 5, and then we have to take 78 divided by 8, and see if those are all the same. So you might need a calculator for this one. All right, so let's try this. 29.25 divided by 3. I think that goes in there. 9 times 3 is 27, so that's 2, so it's going to be 7. And that's 15. I think it's a 5, so 9.75. Okay, so 48.75 divided by 5. Let's see, 9 times 5 is 45. There's 3 left over. So 37, that would be 7, 2 left over, 25, that's 5. 9.75. And 78 divided by 8, same thing, 9.75. So we're going to say it is proportional because the ratios are all the same. The rate of pay, we just found it. See, if you did the y divided by the x, that is the rate because that is the slope. That's the same as doing the change in y over change in x. We only have to do the y over the x only because it's proportional. If it's not proportional, then we have to do the change in y over the change in x. Okay? So anyway, $9.75 per hour. The equation relating x and y. Okay, remember, if it's proportional, we don't need a y-intercept because it's 0. So y equals 9.75 times x. Okay. If y equals 29.25, we're on D now, when x equals 3, find y when x equals 12. Okay, so that's like filling in this table here. Okay, now we have an equation, we could use that. Okay, so this is another way we could solve a proportional relationship, is just use the equation. So if x equals 12, I can just put 12 in there, and y is going to equal 9.75 times 12. Whatever that is. I'll let you multiply that and get that answer. I don't have a calculator with me, so you can do it. All right, let's try the next one. Question 4. Now we have a table here. The ABC Cookie Company sells cookies according to the price chart below. How much would it cost if a customer needed 8 dozen cookies? Wait a minute. 8 dozen, that's not in my... that's not in my table. 8 dozen. I have 2 dozen, 3 dozen, 4 dozen. Okay, so here's what I want to find out first. Is this proportional or not? Okay, so let's find out that. Okay, so how are we going to find that out? Let's do a little division. Let's see, do you want to do cost per cookie? It looks like it's easier to divide that way. Let's try that. Cost per cookie. We're going to do the cost divided by the cookies. It doesn't tell me which one's the x and the y. The cost y. Wait, the cost is y. Oh, okay. So the cost is y. And x dozen cookies. This is x dozen cookies over here. So if we did the cost over cookies, that is the y over the x. So we're in good shape there. So let's do that. For this one to be 8 divided by 2, that's 4. And this would be 12 divided by 3, that's 4. This would be 16 divided by 4, that's 4. This is going to be 20 divided by 5, that's also 4. So the cost per cookies is 4, and that's going to be $4 per dozen. Now that we know that, and we have 8 dozen cookies at $4 per dozen, we could just multiply. You see what I mean? We could just multiply. You see, here's what I mean, in case you didn't get it. So we found $4 per dozen because 2 times 4 equals 8, 3 times 4 equals 12, 4 times 4 equals 16, 5 times 4 equals 20. So we're taking the dozen cookies, multiply by 4 to get the cost. So we have 8 dozen cookies, let's multiply by 4. That's $32. See, proportional relationships are really nice when you know you have one. Okay, if you don't have one, then you have a little extra work to do, because that means that you have to add or subtract something at the end because there's a y-intercept. Okay, so for 7 dozen cookies, we already kind of have our equation, kind of. All we have to do is multiply by 4. 7 times 4 is 28, so that's going to be $28. Okay, so the cost, y, is going to equal 4 times the x dozen cookies. For x equals 7, we just did that. Then it's 4 times 7, and y is 28, and that's $28. That's what we did up here. Ah. Okay. What's next? Oh, last problem. The graph below shows how much you would weigh on the moon if you weighed X pounds on the Earth. According to this graph, if you weighed 150 pounds on the Earth, how much would you weigh on the moon? Okay. Now, this is a straight line that goes through the origin, so it is a proportional relationship. Okay. Since it is a proportional relationship, the equation we could write, see, we can write an equation to help us with all of this. Actually, answer C has us write the equation. If you write the equation first, you can do that. You just need the rate. Y equals m times x. We just need the m. And that m, the rate or the slope, is the change in y over the change in x. It's also, because it's proportional, just any point, the y over the x. Okay, so we could take this first point right here, that one. Now you have to be able to read that point. Okay? If you can't read that point, go to the next one. And then we're going to put the y over the x. So, but remember, the points are always going to be x, y. 6, and what's this? 1. 6, 1. Okay, so we're going to put the y over the x. That's 1 over 6. So y equals 1/6. That's a fraction. That's okay. X. Okay. So if you weighed 150 pounds on Earth, now the Earth weight, that's the X. So 150 pounds on Earth is X is 150. That's the X. And we have the equation already because we just wrote it. Y equals 1 over 6 times 150. All right, you do the math. All you have to do is multiply 1 over 6 times 150, which is the same as taking 150 divided by 6. You do it. Okay. Don't forget to do that. According to this graph, if you weigh 75 pounds on the Earth, how much would you weigh on the moon? Okay, so this is a similar problem. 75 pounds on Earth, that's our X. So X is 75. We could do the same thing that we did before. Y equals 1 over 6 times 75. Okay? Now, in both of these cases, we could solve them with proportional reasoning by making a proportion. And if you made a proportion, it would be like this. Any y over its x will equal any other y over its x. So, remember we label these the first point and the second point. So you could take any of these points, like this one right here. See, that would be 1 over 6 equals, okay, now we have the x, that is 150, and we're looking for the y. Okay, and to find this, here's what you could do. You could find out, what do I have to multiply 6 by to get 150? 6 times something is 150. I have to find it. Well, you would probably divide 150 divided by 6 to find that. But after you find that, then you take 1 times that same number, whatever you found, and that would be the answer we were looking for. You can do that. Okay. Anyway, we already did the last problem. It is y equals 1/6 times the x. See, we wrote it right over here. There it is. Okay, so I hope that helps your understanding of those proportional relationships. You should now be able to do the next assignment with no difficulty whatsoever. Good luck.